An advanced science that translates into fine art, Lost Foam Casting opens a world of design opportunity. By achieving as-cast design complexity and multiple component integration into a single near-net finished part, the Lost Foam process presents substantial value added and total cost advantages unimaginable with stampings, forgings, or other conventional methods. Advantages such as longer tooling life, as foam tooling can last hundreds of thousands of cycles, capable of producing potentially millions of parts. Component weight reduction by as much as 30% due to reduced draft, the ability to achieve thinner, more uniform walls, and elimination of sub-assembly as a result of design architecture that allows for component integration. The reduction or elimination of casting finishing, machining, welding, and balancing operations. Improved component integrity, strength, and appearance. And improved component functionality and performance. In summary, Lost Foam Casting is a type of metal casting process that uses a foam replica as the pattern or core. Coated with a refractory material and packed in unbonded sand, the foam remains in the mold during the metal pour. Under the heat, the foam breaks down and volatilizes into the coating and surrounding sand. As one of the world's largest independent producers of ferrous metal lost foam castings, Citation has nearly 20 years' experience mastering the art and value of lost foam, beginning with the foam pattern itself. At this early stage, Citation works with a handful of select foam providers, like Fosico. From bead pre-expansion and aging to mold press PLC programming, the foam pattern process is designed to ensure the foam maintains strict dimensional accuracy, proper surface finish, and holds a consistent bead fusion level for optimum breakdown when the metal is poured. For many lost foam castings, complexity requires molding and gluing together multiple foam patterns. Here again, the process involves PLC programming and dedicated fixturing, in this case, to ensure precise mold-to-mold orientation. Before casting, each production run mold set undergoes a designated frequency inspection to confirm dimensional accuracy. Next, Citation combines individual foam patterns of the same part into cluster assemblies to meet high-volume demands. These clusters are then robotically dipped in a refractory coating, carefully formulated to make the casting process work.
The coating is a key factor in the entire process and is very carefully controlled through testing for viscosity and permeability because it has to control the velocity of the foam's gas dissipation. Too fast, and you end up with carbon impurities in the casting. Too slow, and the mold collapses in on itself due to the outside pressure of the unbonded sand.
Coated clusters are then dried in a climate-controlled room to ensure stability. When ready for casting, they are inserted into flasks that are conveyed through the casting process. Cluster configurations vary to accommodate a wide range of parts, from as small as 2 pounds to as large as this 800-pound electric motor housing. In the dry media compaction phase, while the flasks are filled with unbonded sand, they are simultaneously vibrated to fluidize the sand and ensure it fills any and all internal passages or geometries in the mold. Next, the molds are ready for the metal. To ensure the highest metallurgical quality, process controls begin with the purchasing of raw materials and continue through the melting and alloying phases where Citation manipulates the base chemistry to create various grades of ductile or gray iron. Multiple chemistry checks and a double nodularity confirmation, both on the pouring deck and minutes later in the lab, ensure the microstructure is of the highest quality ductile iron.
Just like with other casting methods, we test everything to ASTM standards. From a mechanical stress standpoint, lost foam ductile iron is no different from green sand ductile iron. And from a microstructure standpoint, it's actually better because there's no chilling effect on the metal due to the fact we use dry, unbonded sand.
Once poured and cooled, the castings are discharged from the flasks in a shakeout process. As the lost foam process yields no parting lines or flash, very limited gating, and usually no risers, the castings generally can be moved to a simple automated finishing process. Even the surface finish is near net, and the part is ready to be shipped. At the end of the day, the Lost Foam process provides design freedom for obtaining significant weight reduction, better performance, integrity, and aesthetics, and best of all, a lower total cost to the customer.